Why is dimensionality reduction used for data clustering visualization? Imagine trying to understand a complex maze with hundreds of twists and turns. It's hard to see the big picture or find the best path. That's what high-dimensional data feels like for computers and humans alike. When working with data that has many features or variables, it becomes tricky to see how different groups or clusters form. This is where dimensionality reduction comes into play. It's like taking that maze and shrinking it down to a simple map with only a few key landmarks. In the world of machine learning, especially in supervised learning where the system finds patterns without labels, clustering algorithms are used to group similar data points together. But when data has dozens or hundreds of features, these algorithms struggle. The curse of dimensionality makes it hard for algorithms to distinguish meaningful groups from noise. That's why reducing the number of features helps. It simplifies the data and makes the clusters stand out more clearly. Humans are naturally better at understanding 2 or 3 dimensions. If you think about a scatter plot, it's easy to see where the groups are. Dimensionality reduction techniques like principal component analysis, or PC, find the main directions where data varies the most and project data onto those. Nonlinear methods like T-distributed stochastic neighbor embedding, or TSNE, and uniform manifold approximation and projection, or UMAP, do a better job at preserving complex relationships in data. They help visualize clusters that might be hidden in the high-dimensional space. Reducing dimensions also speeds up the clustering process. It takes less time and uses less memory, which is important when working with large datasets. Plus, it helps remove irrelevant or noisy features that can confuse the algorithms. When noise is filtered out, clusters become more distinct and easier to interpret. This makes the whole process more reliable and the results more meaningful. In artificial intelligence applications like ChatGPT, DALL-E, and Midjourney, data often comes in high dimensions. For example, text embeddings or image features can have hundreds of variables. Visualizing these in a lower dimension helps developers see how the model groups similar ideas or images. It's a useful way to check if the AI is understanding concepts correctly or if there's bias present. To sum up, dimensionality reduction makes data easier to see and understand. It transforms complex high-dimensional data into a simpler form that reveals the true structure. This helps in visualizing clusters, improving the performance of clustering algorithms, and making AI models more transparent. Whether you're working with images, text, or other kinds of data, reducing dimensions is a key step to making sense of it all.